Hello, my name is Marco Carloni, and I'm the founder of Linux Technologies. In this video, I'll give you an introduction to SIMAC, which is an online linear accelerator simulator. We start the simulator by selecting an energy from the pull-down menu. With an energy selected, the operating parameters of the machine now appear. The black numbers are input values to the simulator that can be adjusted. The green values are then the operating parameters of the accelerator that the simulator calculates. By hovering over one of the green values, you can see what value it represents. Also included in the display is the machine state info, which includes flatness, symmetry, and depth dose parameters. If you click on one of the black numbers, you can see what the number represents, and you can also find a way of adjusting it. So in this instance, we changed the klystron voltage from 104 kilovolts to 110 kilovolts. The effect that this has is that it will increase the electron beam energy from 6 MeV to 6.34 MeV. However, we also see that the dose rate declines from 133 centigrade per minute to 50 centigrade per minute. The reason for the decline in dose rate is that we've introduced a mismatch energy between the accelerator output and what energy the bending magnet will allow to pass through. You can learn about this in the Linux lessons that accompany this simulator. You can also choose between open loop and closed loop modes. In open loop mode, the machine dose rate is set by the pulse repetition frequency, which is selectable directly from the pull-down menu. In closed loop mode, the machine dose rate is set directly, and the machine then sets the pulse repetition frequency needed in order to achieve the desired dose rate. There's also an analysis tab, which will bring you to a screen which shows you some of the information that can be plotted using SIMAC. So in this analysis tab, you can see the radial and transverse profiles, as well as the depth dose. If you scroll down on the analysis tab, you can see some plots of the angular intensity of photons from the target. Currently, the depth of the profile shown in the analysis tab is fixed at Dmax. In future versions of SIMAC, we'll make this adjustable. Similarly, in the current version of SIMAC, the field size is selectable by only one parameter. In future versions, we'll make all 4 jaws independently selectable. There are also beam steering values that you can adjust, as well as gun beam errors. For instance, if you introduce a small gun error in the radial direction, you can see the effect this has on the radial symmetry. You can also visualize this in the Analysis tab. You can then adjust the buncher and position coils, and then correct the symmetry error. By clicking on the flattening filter, you get a drop-down menu, which allows you to change flattening filters. Then when you click on the Filter tab, you can build your own flattening filter. On the Filter tab, you can edit the flattening filter thickness and save a new filter to use later. The first step is to choose an existing flattening filter. There are default 6 MV and 15 MV filters, which gives you a place to start. We've also added some other filters just so you can see what SIMAC can do. When a filter is selected, the filter thicknesses are populated, as well as new filter thicknesses. These are made to be the same as the existing thickness, but you can be adjusted by selecting them and using the arrow keys. When you're done creating your flattening filter, you can give it a name. You can also select the material you want for the flattening filter. Currently, we only have tungsten and copper, but we'll add more materials soon. When you're happy with your filter design, you can save it and then use it again later. As an example, we can use the flattening filter design for the 15 MV beam, but substitute copper instead of the default tungsten value for the material. We can then apply it to a normal 6 MV beam. and as a result, we'll see that the beam is very unflat. The beam profiles can then be viewed in the Analysis tab, where we do in fact see the beam that is not very flat. You can also simulate a filter that has zero thickness, which simulates a flattening filter free mode. And the result in the Analysis tab shows profiles that have a beam which is much more intense at the center of the beam and then drops off sharply at the edges, which is what you'd expect for a flattening filter free mode beam. This is the conclusion of the short introduction to SIMAC, our online accelerator simulator. We have seen that with SIMAC, you can adjust many of the input values or voltages and currents of the accelerator, and then see what effect it has on the operating values of the simulator. This includes the machine's dose rate, but you can also adjust steering values as well as manipulate the flattening filter, and then see how this affects flatness and symmetry. We hope you enjoy the simulator.